Hey everyone. I wasn't originally going to stream tonight, but I've been thinking about this project a lot, and I want to keep going on it. We got some good momentum, and wanna wanna keep going with it. So yeah, fired up a stream, and I'll start just by showing what we've developed. All of the code that we're writing for this project, we're going to write on stream. So if you're interested in more detail, what we did the last time, you can go back to the first two streams. But yeah, let's get started. So first, I just wanted to show something cool. So I found this program, and I'm still tweaking the settings a little bit. I found this neat program that kind of simulates a retro terminal, and I'm just going to use that a little bit to add to the flavor of this. Eventually, what we'll probably do, uh, if this ends up being something that is sort of a nice project, I'll write my own retro terminal emulator for the Python version. But for now, we can use this, and this is just a nice way to visualize the project separate from the PyCharm window that we're using to develop it. But just to review a little bit what we've done so far and where we're going with this, I was inspired by gaming historians' Oregon Trail video to try my hand at developing a text-based survival game like Oregon Trail, but I'm making a sci-fi fantasy game that's set in my fictional universe that all my different projects share. And I thought it would be kind of a neat chance to stream a project from scratch, show what I think of as clean Python code. We're gonna use Python code to write this, but trying to write it in a very simple way that's amenable to eventually porting to a 8-bit microcomputer like a Commodore 64, ZX Spectrum, or even DOS PC. So, and it's also a chance for me to revisit a bit of my childhood, since I used to write little games and programs like this in Quick Basic when I was first learning how to program, and I was inspired to do that by this book, which belonged to my dad, that had some games like this in there. So let's take a look at what we have. So everything is in one Python file right now that's currently about 500 lines long. And in the first episode, we kind of made an outline of the different features that we want to have with this. So here we have some control codes for printing text in color. Unfortunately, this retro term doesn't display the colors correctly, all the colors correctly, but it still kind of works, so we're going to use it. And then we implemented data structures for different things like characters, the spacecraft, resources, the party, which consists of the spacecraft, a list of characters and resources, the state, which is the current dungeon that we're in, the depth, because it's sort of a linear map, and the day in our quest. And our dungeon list consists of a list of chunks and a list of landmarks. Now, the game type here is going to be kind of like a linear. You're traveling. There's not really a map that gives you options where to go. You're traveling on a linear map like in the Oregon Trail. And then the game kind of consists of resource management, as well as dealing with different random encounters like like with different enemies or kind of like hunting mini games, things like that. And the fun of these games and the addictiveness is kind of in the emergent behavior of these different random systems. And they're kind of simple and fun and addictive. So I'm hoping to try to build a game like that. So we sketched out and then some things that I'm adding for interest are like character types, so classes of characters. Class, that's the word I was looking for. Um, well, no, it's not class. It's really more race, but um, some character types. The characters have stats too, unlike Oregon Trail. So there's a couple of features that will kind of factor in, and oh, they also have families, so that might affect certain things. The spacecraft has a type, and then there's different types of segments of the map that might play into how some of these random effects work. And the story for the game is that you are a party, like a treasure hunting party, who takes a spacecraft through a magic portal into these tunnels beneath space that are of an alien origin. And you're trying to find artifacts and eventually get to the end of the tunnel to get your goal, which I have not fleshed out yet. That will probably be part of the party creation process, is that there will be sort of a random goal that's chosen to give some flavor for that. Yeah, so then we wrote the main game loop. We need to do character creation menus and stuff yet. But yeah, so we have and we're just instead of going through the character creation and the random seed to generate the dungeon, we are just doing we just have like a default pre-generated party and dungeon that we're using for testing, so we don't really have any surprises. But we do have some random behavior. I'm not setting a seed, so it actually varies from run to run, which is kind of fun. And basically, the current random event is that there's like a 25% chance that you basically just complete, like everybody dies. I won't have anything like that in the final game, but just a simple way. So if we fire this up, so you get our little title, and we're opening our portal to the deep, and here's our kind of main screen, kind of like our travel screen. And let's see, can we adjust the height of this? Nice. So we can, I think it looks like it probably did default to 25 by 80. So we can start doing some things now where we're starting to make this appear more like a game screen as well. So yeah, so this is kind of like our main screen. So basically every day we can either continue traveling in our ship into these tunnels, we can check our status, which we haven't implemented yet, disembark, and that will give a chance to do different random encounters or find different things, use skills, or abandon the quest, which is quit. So right now we can't really do anything except continue, so we'll continue, and then right away we died this time. So let's start it again. And continue. Oh, here we made it to day 3, and each day we're traveling 10 kilometers further into the tunnel. That number should probably be a bit higher, I think, maybe like 100 kilometers. But yeah, so what I was thinking to do today is I want to start getting some interesting random events that use the different resources. Maybe get the status screen working. And then I wanted to just play around a little bit with adding a little bit more visual interest, because I think that's kind of important. So I might actually experiment with some procedural graphics for the tunnels. And that I didn't prepare anything ahead. Um, uh, and that just might be a complete failure. So we're gonna get that out of the way early, and if it's a complete failure, then I'll do some research and come back with something better. But we're gonna just try that and see what happens. But I'm kind of inspired by this terminal to add some functionality to sort of make the game feel a little bit more real in terms of how it's using the screen. So we're going to do that first. So we have a couple of functions right here, and I'm going to just start cleaning some of this stuff up. So So, a couple things that I was thinking about here. So, for one thing, we can clear the screen. And I'm going to start maybe using term as a prefix here. So, we can clear the screen by printing 25 lines if we know the screen is 25 lines high. I'm going to just add a constant up here for the terminal lines. Probably in a retro system, you'd have like 20 lines and I think 40 columns. Here we have 80 columns, so things will just look a little bit narrow, but that's okay. And I've resisted the urge so far to move things into separate files, but I'm starting to feel like doing that, so I might. So clear the terminal by printing blank lines. Okay. So basically just for something in the range of term lines, cprint empty. And something that I also want to do here is we're going to add a little bit of visual interest by adding some very slight delays to things. So nothing that's going to like interfere with the ability to test it, but just having things not appear instantly. Number one is going to make it feel retro, and number two is just going to make it feel more grounded, like something is actually happening. This is something that I definitely experienced when I was writing these kinds of games when I was a kid, and I would add these little delays. So we'll just add a let's see here. So line delay. I think we want probably something like that many seconds. And time.sleep line delay. So let's now let's add these clears in some different times. So I thought I had press. Oh yeah, here's a press enter to continue. And I'm just going to make that message a constant because we're going to use it some different places. Start cleaning things up a little bit here in terms of constants. Maybe we'll add an ellipses. So yeah, so we will do a C input, press enter, and then we'll do a term clear. And then basically after every iteration of our loop, we will do a term clear. And you also have to think about whether you want to do this before or after, but I think we can do it here. And then we might also do it inside the loop if we are, like after checking statuses or things like that. But let's just see how this looks. So now we can press enter to continue. Oh, invalid input. Okay, that's definitely too slow. All right, let's see here. And that term lines, did I not put 25? That's interesting too. Oh, I know what's going on. Actually, do I know what's going on? We'll figure it out here. So the line delay. Just a second. Delay. Yeah. So the line delay needs to be a lot quicker. And let's see here. This to continue needs to be a string here instead of int, because strings can be empty. So, and they could really be any input, so that's what we want. Oh, I lost the terminal here. Will it remember what I... Yep, it does. Okay. Okay, so let's see here. So in another episode, I can talk about the Python environment. It doesn't really matter a ton here. Actually, do I need to... Oh, I know what's going on. Yeah, that isn't going to work because I need to be able to know that I'm starting at the top line. Oh, that's unfortunate. No, it's still not. Maybe I'm confused about. Let's see here. Oh, yeah. It's always gonna. Yeah, I guess that doesn't quite do what I was expecting it to do. Um, Let me just quick check if there's a quick way to actually clear the terminal. I wonder if I can. This is some real live coding here. True live coding. Yeah, there. Okay, that's what I wanted. So I can run the clear command, and that gives me get the animation to bring stuff off the screen, and then make sure that it starts at the right place. So actually, let's we'll change this to term clear scroll, and then we'll make a new function that's just term clear that does the OS system clear. And let's see here, at the beginning of main, we'll do term clear, and then that should, yeah. Yeah, cool. That's kind of the look that I want. And at the end, the very end of the program, before we exit, we will just do a new line. Okay, cool. So let's actually do a couple things here. I think it's sometimes important to just spend a little bit of time making things look nice. So I'm going to do that here a little bit. And then we're going to implement a status the status screen. We'll implement the status screen. We'll try to get some random events going, and then I want to experiment with procedural ASCII art for the main exploration screen, and then we'll call it good. So not a super long stream tonight, hopefully. Okay, do this. See if this looks any better. Okay, nice. And this terminal just does not understand. It does not understand light and dark colors, unfortunately. So, that's okay. Whew, we're making it a long way this time. Okay, there we got Eaton finally. Okay, so yeah, let's take a look at a status screen. Yeah, status screen and then some random events. Okay, so I'm gonna actually start making some different functions here. And let's see, why isn't this guy docking? Let's see here. To Windows. There we go. Okay. So you can see with this file structure, this really shows our different parts of our file. So we don't have a whole lot of functions right now. We just have our main run inside, which is the main game loop when we're inside the dungeon, and our some of our terminal stuff. I think, oh, yeah, these are showing up like that because they're new. Let's just clean this stuff up a little bit. We should also probably double check our feature list here to see if there's anything that we are missing. Yeah, so what we're going to be showing in the status screen is showing our stats for our party members, as well as our different resources. And the resources that we've defined so far are money, spacecraft parts, provisions, ammunition and ethereal blades, and artifacts. So, yeah, let's make a new function for the status screen. And I think, like run inside, this is going to take all of these things. And so let's start with the dungeon chunk description. So we're going to have a more complete description. I'm actually going to split this so we can reference our main screen. So this we can just do status and we don't need a variable for that this time. Actually, I don't want this to be an underscore. I want that to be a So I can just go like this. And let's just check how long it needs to be here. Okay. So our detailed status is going to be this, and this is a list of strings, and yeah, for both the landmarks and the chunks. So we can print out something like, and let's again go back to our run inside. Up. And then for line in desk, actually we can just range, actually line in enumerate. So for each line, if index equals 0, then we can say the party.ship spacecraft.name has entered, and this is prefix, and then line equals prefix plus line, and then we'll see print the line. So that's our longer, that'll be our longer description of where we are. And then we're going to print the status of the party. And I think the way I'm going to do this is we're going to allocate a certain number of columns to each party member. And I think we can do because if this was a vintage, let's think about this here. So if this was a vintage system, we'd have 25 columns. If we have 3 characters, then we can do, let's see, 3 times 8 would be 24. But we also need some blank spaces. So I think we better limit our width to 7. So that means that our character names will have to be like limited in the number of and the size. Let's just see how this looks. So, and we know we're always going to have 3 characters, so that makes this somewhat easier. So we can do, let's see here, party, and let's just do A equals party dot characters 0 BC, just so we don't have to actually, and we can even do better than this. C characters, and then we can do char A dot just left. Let's see, is it left justify? Yep, left justify, call width with spaces. I think that's how ljust works. I always forget how ljust works. Yep. And it's not gonna like that inside. Does ljust? I think ljust uses. I think ljust uses spaces by default, doesn't it? I guess we'll find out. We're gonna end up splitting this across some lines, but that's okay. It's really kind of relaxing doing simpler programming like this after spending a bunch of time writing code that's a lot more complicated. Now, here's a question. How long are my type names? One, 2, 3, 4, 5, 6, 7, 8. Sad. Okay, so we might have to do an abbreviated 1, 2, 3, 4, 5, 6, 7. We can just do that for actually, yeah, we can just map. Oh yeah, we've got to send this through this dictionary anyway, so we can do a short name short. Do a short name anyway. So we'll just zoom out a little bit here. Char type dot name short. Look at that. Oh, and this has to go like this. Yeah. Cool. Okay, so we've got the name, the type. We want to do the families. And actually, yeah, so we can do this. I know I used already, so we've got to refactor if we're going to rename it. Let's see, 1, 2, 3. Okay, cool. So family And just while I'm thinking of it, we should have like a none family because our character might not be associated with any of the great houses of the Rami. Or actually we could call this unknown. And that fits. So that can stay full length for short. Okay. So now we want to do stats. So this I think is going to be a little bit simpler. Now I forget. I think actually no, we do have to call string on it first. So, and let's see here. These I don't know why it does this sometimes, where it should be smart enough to know that these just destructure into characters. It's like, come on. Yeah, okay. So the format is going to look like this. We convert to a string. We adjust out to column width, and then we'll actually we can even append the actually, that's what we want to do. We want to adjust to column width -2. Yep, adjust to column width -2. Prepend the stat name. There. That's what we want. So now we'll repeat this for B and C. And you know, it's like if I was writing this for modern purposes, I might figure out some way to clean up the boilerplate here, but I don't want to get too complicated with it. Actually, yeah, and I thought I had that. I thought I had physical first. Now, the other thing that we can do here too eventually, and this would actually, now that I'm thinking about it, would be a good reason to do this in a loop rather than writing it out like this, is that we want to be able to change colors and stuff. And do other little pieces of logic. So yeah, okay, how about we'll take a look at this and see how it looks just as is. So there's a couple stats missing, and then we'll go back and we will rewrite it with loops because I want to be able to do different colors and things. Like if stats are low, like show them in red or something. And then we also want to do like maybe labels, like sick, injured, insane, etc. Oh yeah, and then we've got to do our resources too. So craft and resources. If I can, it'd be nice to fit this on one screen, but I'm not sure that that will be possible, so we'll just have to see. Okay. Whoops. Didn't need to push. Okay, so. Oh yeah, and I didn't actually implement it yet, so let's do that. Okay, so if so let's see here. What's not implemented? Abilities, disembark and abilities. So if choice equals 3, choice equals 4. That's not implemented yet. Otherwise, if choice equals 2, then we're going to status party state dungeon. All right, and quit this. All right, so we're going through into the portal, and actually we want to clear the screen first at the beginning of the status. Nice. Okay, and I can see right now our names are too long, so we need to control that. We should add a new line here with on the prefix because we're trying to still kind of stay within 25, but otherwise this looks kind of good. So term clear scroll, and has entered. And we can just print this directly. See print. And do that. Do another C print here. And let's just set it to continue. Nice. Okay. All right. Nope. Forgot my little F string there. Okay, so oh yeah, it's not 25, it's 40. It's 40 is the 40 is the width that I'm working with. Uh yeah. That gives us a lot more room. Or 64 terminal columns. 40 columns. Yeah. Okay. I was like, this looks a little narrow. And what I'm going to do is I'm going to add back in the logic that trims the lines that I print at 40 so we can see descriptions that need to be shortened. But yeah, 40 gives us a lot more to work with because now we can make these columns like at least 10 or 12. See, yeah, 12 times 3 is 36. So we can make these a full 12, and we could give these a little bit extra. But yeah, let's do this. Let's do this in a loop now. So we still are going to have these repeated loops, but we're going to build up. Yeah, we'll do a repeated loop to build up a line that will print. So and we can just loop over party characters now. We don't need A, B, and C anymore. And we can, yeah, okay, cool. So line plus equals and then we can just add in 4. And then at the tail end, we will see print line with light cyan. And I'm going to just make that tweak to C print right now. So we'll say if length of line is greater than 40, warning equals what's a good character that we wouldn't see otherwise? Maybe ampersand. I don't really like using ampersands, so we'll do that, and then we can see where we're running off. Okay. Get rid of this because it knows that it knows that character is a character now. It doesn't when we just destructure. Whatever. Okay, so same thing again here for char in. This is actually quite a bit cleaner. Line plus equals, and we can. I think I'm still going to keep the short types because that just having that capability is nice because it will let us like have it'll let us have like additional characters or things like that if we want. Okay, oops. Additional characters, not meaning characters, but symbols, glyphs, and family is pretty much the same here. Family name short. family. Okay, now the rest of these is just pretty simple copy paste, where we are going to do P E knowledge and whoops P K and S for and short, gotta add our 2, 3, 4, 4. Cool. Whoops, and this guy needs to be renamed. I misspelled that. Okay, so let's run this and see how this looks now. Oh, interesting. So why am I getting all those ads? If length of line. Oh, I need to do this first before the L just out to 40. Duh. And we want to trim here. So line to 40. We don't need the L just, and we can add the warning here. Not lube. Line. Okay. Yep. Okay. Okay, so we are exceeding our, yeah, because we don't actually have 12. That's miscalculated. But we don't have to worry. So what's here? I did 8. So I think we could do, yeah, let's try this. Yeah, and it looks like I'm not adding something in right. So we've got the name short of the type, L just to call width plus. Okay, so it's the family that's scooped up. Yeah. Oh, that's why. These are only 3. How does that look? We'll do 4. And we'll just do this ahead. Yeah, that's looking good. Okay. Just wrap these to fit in our lines as long as we notice that there's a problem there. Okay, so that's 40. That was 40 exactly. Modern IDs are nice for figuring out these things sometimes. Something I can do too is I can write a little bit of code that just checks and makes sure that none of these lines are too long. But I don't want to like that repeated into. We'll fix that later. Okay. No. And typical Python forgot to add commas back in. Okay, cool. So we can definitely fit a little bit more here. Maybe we should do the ship status. The other thing we can do is we could combine. We can save ourselves a couple lines here by combining knowledge and sanity together. I think we'll probably want to do that. The other thing we could do is we could separate this into like a look around kind of thing. So, okay. We're coming up on an hour here, or we are a little bit past an hour. So just trying to think what I want to. I kind of want to finish this status screen so we don't have to work on that next time, and then we'll save some of the other stuff for later. And this stuff will be pretty simple. So so we'll do the spacecraft, and we'll do the spacecraft up here above the characters. So, and this we can definitely combine some some lines in. So spacecraft.name. We'll wrap this. Look familiar. Name. And then here we're not trying to fit columns, so you don't have to worry as much about trying to justify stuff. So we can say structure spacecraft.structure out of spacecraft.structure max, and shields max. And I think that's it for the spacecraft. Stuff. Okay, and okay, so that's the spacecraft, and then resources. So these are all just sort of distinct. So remind ourselves of what they are again. So parts. Oh, and did I not actually make one for money? Yeah, that's funny. And we'll call resource, we'll call that credits. Because that's a good sci-fi name. Now, we'll see. I bet this is going to be too much to fit on one screen. Okay, so it almost fits. And yeah, we're running out of space for the spacecraft. Um, well, let's see here. I think here's what we're gonna do. So we're going to move. We don't need to say spacecraft here because it should be pretty obvious what this is. Then these two things will go, these three things will go on three separate lines. Okay. And do a nice thing like this. And then this this we will save for a different mode, like a look around mode. So maybe just for the sake of completeness, and not getting too far ahead of us, we'll just implement that right now. Observation. I think in Oregon Trail this is called it's like check your surroundings or something. Me. Gotta have a, where's the screenshot of the 1985 one? Here we go. Oh yeah, it's called like size of your surroundings, I think. Would you like to look around? So we'll just call this observation. And maybe, you know, maybe different character types with different ability levels could give you some clues as to what kind of random encounters you might size up the situation. That's the would give you some clues to what kind of random encounters yeah, press return to size up the situation. Yeah, so yeah, so that way so that way this has some purpose to it. And let's just go like this. This up. So yeah, this could be kind of a rich screen. I need to look at in. I think the size of the situation thing in Oregon Trail is basically the status. So it ends up being basically the same thing. But we can do whatever we want because we're making this ourselves. That's the fun thing about programming, is you can do whatever you want. Okay, so yeah, let's take a look at this again now. So all right, so the status screen now looks good. Okay, I need to look up the actual ship type instead of just the thing, and I need an extra printout there, but that's looking good. So this is spacecraft type dot names, and that should just be name, not names. Because it's a map that gives us the name. Is there other stuff called names in here? No. Okay. And now let's add a observation. So status observation and 5, 6. So now less than 6. If choice is 6, then we quit. If choice is 4 or 5, we say that that isn't implemented yet. If choice is 2, then we'll do status. If choice is 3, we'll do our observation. And disembarking and skills will be next. So here we go. Transit. There's our status. Oh, I forgot to add that extra print line after here. That's okay. And we should do a dash here as well. Observation. So there we go. And then we could give some additional messages. Looks like we might have frozen up here. Been having internet trouble lately, kind of frustrating. Yep. So, and it looks like things are working properly. We don't have the day or the depth incrementing when we're not traveling forward. Like we can just keep going on status and observation, and it's not incrementing, so that's good. And does our status make sense as far as the actual things? I think it does. So that, let's just check it once more with those fixes that we made. Okay, cool. So status screen, I would say, is done. And let's just see how long it takes till we get eaten. Whew. Ooh, we're really close now. Oh, we failed. All right, so, yeah, some good headway here. I think probably what I will do is I will do some experimentation on my own as far as generating ASCII art, um, ASCII art for the view goes. But I'm liking how this looks. I think we did some good work here today as far as like the formatting fixes and things. So in the future, like that'll be ready. Let me actually just, while I'm thinking of it, uh, let me just fix the depth to be 100 kilometers. And yeah, so next time we will work on some fun random encounters and things that use the resources and abilities, and we'll be able to check that stuff easier now because we can see our status as far as what our resources are and everything. So that'll be easier to do now as well. Yeah. All right. Well, thanks everyone for watching. If you haven't taken a look at the first two parts of this and you're interested in the complete process, definitely go and check those out. And we'll try to pick this up again soon. This is been a fun little project, and I'm anxious to see it actually running and interacting with resources and random events and stuff. So, all right, thanks again. Have a good evening.